Welcome, everyone. My name is Yamil Guevara, and this is the second video on a video series on machine learning algorithm. By the end of this video series, you should be a machine learning engineer. We will cover every single machine learning algorithm, and I want you to apply all of this machine learning algorithm at your job. And here's why. I really don't want you to watch these videos for the sake of watching them. I want you to watch these videos and apply them at your job so that you can get a promotion or that you can get a pay raise. I want you to apply this knowledge gained from these videos for your own benefit and for the benefit of your company. So please, after watching each video, please go back to your job and apply that knowledge gained from these videos to your job so that you can get a pay raise or get a promotion or become a machine learning engineer at the end. Well, I want you to, if you like these videos, please click subscribe, click like, and definitely make comments at the section below of this video. Now, in this video, we're going to be covering KNN. What does KNN stand for? Well, KNN stands for K nearest neighbors. It is a machine learning algorithm. So let's discuss before continuing. I would like to discuss the data set that we are going to be using in this video lesson. I want you to think about the following. Imagine a telecommunications provider that has segmented its customers based by service usage patterns, categorizing the customers into four groups. If demographic data can be used to predict group membership, the company can customize offers to individual prospective customers. It is a classification problem. That is, given the dataset with predefined labels, we need to build a model to be used to predict class of a new or unknown case. Now, in this video lesson, we're going to be focusing on using demographic data such as region, age, marital, to predict usage patterns. The target field is called CASCAD, which means customer categorization. And it has four possible values that correspond to four customer groups. And the customer groups are as follow. Number one, basic service. Number two, e-service. Number three, plus service. Number four, total service. And our objective in this video is to build a classifier to predict the class of unknown cases. We will use a specific type of classification called K nearest neighbor or KNN. Okay, so we're going to be using KNN machine learning algorithm to build this classifier. Okay, to predict the class of unknown cases. Okay, so as usual, the first step in building any machine learning model is to import the libraries. So let's import our libraries. Okay. Here. We're going to be importing NumPy as NP. We're going to be importing matplot library, right? Python plot, plt, import pandas. We always import pandas. Always, 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 always. Import sklearn. Oh, I made a mistake here. Not import. From sklearn. Import pre processing. Oh, by the way, in this video, I'm going to be using Jupyter Lab. And in Jupyter Lab, when you click the tab button, it autofills for you, or it gives you options. And that's to make it easy for me. So you'll see a lot of times when I'm actually typing, I will click tab and it will autofill for me. So let's run this code to make sure there are no errors. Okay. So far, so good, everybody. We have imported. So that's the first step in building any machine learning model is to import our libraries. In this case, we have imported NumPy. We have imported pandas. We have imported scikit-learn, and matplotlib, okay, which is the library. So let's continue. So what's the second step? The second step is to actually import our data set. And I'm going to be importing our data set and saving it in the variable called df, which really stands for data frame. So I'm going to use Panda to actually import this data set. Okay. And the data set is called Tele Customer 1000 and CSV. And I don't want to just import it, but I always like to view my data set. I like to view the first 4 rows of my data set. The way you do is by df, by typing df and heading. So let's run our code. So here it is. Here's our first row of our data set. We have several variables here. We got region, tenure, age, marital, status, address, income, education level, employment, retirement, gender, residence, and customer categorization. Okay, so we are going to be predicting this, the customer categorization of customer cat, uh, using this classifier model. Okay, so now that we have imported our libraries, we have imported our 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 data set. Okay, our data set. It's time to define our features. So before we define our features, let's look at our columns. Okay, so let's type up df columns. Let's look at our columns. Okay, here are our columns, our labels. Okay, so we're gonna be selecting our features. Okay, which are gonna be part of the x variable. So let's import these features. Our first feature is gonna be region. Okay, our second feature is gonna be tenure, age, marital, address, income, education, employment, tenure. Let's run our code. Okay, so far no problems. Okay, you guys are doing an excellent job. Okay, so we have selected or defined our features for X. Okay, now let's define our vector, our target vector, which is customer category. Okay, so let's do that. Y, yeah, customer class category values. And as always, I always like to look at my data. Let's look at this data. Let's run the code. Okay, so far so good. Okay, so what is it that we've done so far? So far we have imported libraries. So far we have imported data set. We have selected our features. We have selected our target vector. And now it's time to normalize that data. So what does that mean, normalizing the data? Now, when you actually normalize a data, you give the data a zero mean and a univariance. And the reason this is actually a good practice is because machine learning algorithms such as KNN uh, is going to be measuring the distance from each data point, and the distance needs to be standardized. It cannot be. Sometimes you can have, if you think about it, you can have data that is going to be measured in centimeters, and data that's going to be measured in millimeters. So that's going to be different measurements. But you want to standardize the measurements so that way you can actually actually are able to measure the distance from each other more accurately. So that's what data normalization or data standardization does. And that's what we are going to do right now. We're going to standardize our data or normalize our data. So let's do that. And of course, I always like to look at my data, see how it looks. So let's run the code. Okay, there it is. Data has been standardized. Okay, and is ready to be processed. Yeah, you definitely want to standardize the data. That way, it is easier for the machine learning algorithm to measure the distance from each point using standardized information. Actually, before we continue, I want to discuss something about sample accuracy. Okay, it is very important that you understand this. Out of sample accuracy is the percentage of correct predictions that the model makes on data that the model has not been trained on. Doing a train and test on the same dataset will most likely have a low out-of-sample accuracy due to the likelihood of our model overfitting. So it is very important that our model have a high out-of-sample accuracy because if you think about it, the purpose of any model is to make correct predictions on unknown data. So how can we improve the out-of-sample accuracy? Well, the easiest way is to one way of doing this is to use an evaluation approach called the train test split. Now, the train test split involves splitting the dataset into training and testing set respectively, which are mutually exclusive. After which you train with the training set and test with the testing set. This will provide a more accurate evaluation on an out-of-sample accuracy because the testing dataset is not part of the dataset that has been used to train the model. It is more realistic for real-world problems. Okay, so now that we discussed that, let's continue. So, just like I said, we need to split our data set into two sets. One to train the model and the other one to test the model. And that's what we're going to be doing next, okay? So from sklearn model selection, import train test split. Okay? Train test y train y test. And now train test split test size equals 0.2 random state equals 4. Okay, now the we are going to use 20% of our data set to test the model and 80% to train the model. Okay. Now, I set the random state to 4. Now, if you want to get the same results that I'm going to be getting in this video lesson, you need to set your random state to 4. If you set your random state to any other number than 4, you are going to get a different result than my results. Therefore, if you want to get the same results, make sure you set the random state to 4. Let's run this code. Okay, so far so good. We have split our data set, 20% for testing and 80% for training. Okay, so far we've done great, guys. I'm really impressed by all of you. You're doing an amazing job, and I'm really impressed by you. So we need to definitely continue moving forward. So now that we have a split up data set, it's time to create our model, our KNN model. So let's begin. Sklearn, learn nearest neighbors, okay. Import classifier. Excellent. Let's run this code. Excellent. So far, so good. Okay, so we are going to be setting our K to 4 for now. But in the future, we are going to be changing that K to the optimal K. But at this point, we don't know the optimal K for this data set. So we're going to set initially the K to 4, okay? But it will be changed in the future, okay? So let's train our model and let's do some predictions, okay? Our model is going to be called Nate. Training set. And of course, I want to see what's in there. Okay, let's run this code. Excellent. So our K is 4. So that means that we're going to be classifying our unknown data set based on its 4 nearest neighbors. So we're going to be using the 4 nearest neighbors to classify our unknown data set. Okay. So let's continue. Let me scroll up. Okay, now let's do some prediction here. Okay. So y hat using our model, which is Nate, we're gonna be doing some prediction. Prediction. And of course, I always like to look at my data. Okay, let's look at predictions. Oh, there they are. We just predicted. Okay. So now we need to, now that we have created our model, it's time to evaluate the accuracy of our model. Okay. All right. So let me see. So remember, when it comes to the accuracy evaluation, in a multi-label classification, the accuracy classification score is a function that computes the subset accuracy. This function is equal to the Jacquard score function. Essentially, it calculates how closely the actual labels and predicted labels are matched in the test set. So let's calculate our accuracy. Okay, let's see how accurate this model is. So from sklearn, import metrics, print, train, set, accuracy, accuracy, metrics, accuracy score, y, train, print, predict, Int test set accuracy. And of course, metrics, accuracy, score, y test, y hat. Let's run this code. Okay, here's our accuracy level. So our accuracy is actually about 0.32 on our test set, 0.32. It is a very low accuracy, but we are going to try to find an optimal K to increase our accuracy to a higher score. But right now, really our accuracy is at 0.32, which is not high. But the whole point of this video is not really to have a super accurate model, but it's actually how to create a model. I'm showing you how to create a model. So now that we have measured the accuracy, now that we have actually created the model, uh, what about other K? What's the optimal K? We want to find the optimal K to increase the accuracy of this model. So let's do that. I'm going to show you how to find the optimal K. To find the optimal K, here's I want you to think of the following, okay? Think about the following. This is what we are going to be doing to actually find the optimal K. Listen carefully. K in KNN, in the KNN algorithm, is the number of nearest neighbors to examine. It is supposed to be specified by the user. You're supposed to choose the K. So how can we choose the right value for K? Think about it. How do we choose them? Well, the general solution is to reserve a part of your data for testing the accuracy of the model. Then choose K equals to 1, use that training part of your modeling, and calculate the accuracy prediction using all samples in your test set. You need to repeat this process, increasing that K, and see which K is the best for your model. And that's exactly what we are going to be doing right now. We're going to be actually predicting the accuracy of all the samples, and then we're going to be choosing the optimal K. So let's do this, okay? Uh, let's begin. We're going to be using NumPy as always. 0, 0, 0, 0, 0. NumPy again. We're going to be using NumPy. Zeros. We're going to be using a loop to go through all these um, iterations, to go through all the samples during the predictions. So we're going to be using the loop, the for loop, okay, and we're going to be using the range, and we're going to be using K. So we're going to be predicting model uh, 10 times, okay? So we are going to be we're going to be creating and predicting our model 10 different times with using 10 different K numbers. Starting with K1, here's K1, here it is, and then we end up with K10, which K10 is actually KS, and KS is 10. So we're going to be going through K1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in each loop and increasing the K from 1 all the way to 10. And each time we do that, we're going to be actually be creating a model and testing the model accuracy using different Ks. That's what we are doing right now. NumPy, std, NumPy, square, sheet, 0. Okay, so here's what we are actually going to be doing. We're actually going to be creating the KNN model. Uh, and each time we create the KNN model, we're going to be using a different K. And we're going to be starting with K1, and we are going to end up with K10. So we are, in reality, creating 10 different models with 10 different Ks. And then we're going to choose the model that has the highest accuracy level based on the K that is chosen. So let's run this code, and hopefully there are no errors. Oh, there are errors. KS is not defined. That's because I made a mistake there. It should be KS. There it is. Excellent. Okay. So let's find out using this information. Let's find out what's actually the optimal K. And let's plot the optimal K using some plotting data, okay? So let's use plot range. Yes. what we're doing here is actually selecting the colors that we're going to be filling in our graph. So our graph is going to have a green color. So I'm just selecting the colors here, guys. I know it's going to take a little bit a while, but it's okay. Okay. Just selecting the features of our graph. That's what I'm actually doing here. Okay. It's not really that accuracy. Hmm. Okay, so we are going to be plotting our data. Okay, and I made a graph with green coloring inside of it. The Y label is going to measure the accuracy. The X label is going to measure the number of Ks. It's going to depict the number of Ks. And before we do that, I want to do something else. I want to print the best accuracy was with mean max with K mean. Let's run this code. Hopefully there are no errors. Okay, as usual, there's some errors. Don't worry about it. We'll find the error. So what's the error here? STD account mean is not defined. Oh, it's not defined. So let me see what I do. STD, STD, ACC. I know why. Because they're not the same. Okay, let's do it. Let's run that code one more time. It's still an error here. Let's do it one more time. There it is. Okay, sometimes yeah, you do a typo and that can create problems. You know, you just gotta find those little typos and in order to avoid those problems. So here the result. Here's our graph, and it shows the accuracy of each iteration of the model that we created. We created 10 models with 10 different Ks. The first model had 1K, and the accuracy level was 0.3. Then the next model had 2K, and the accuracy level decreased actually. Then the next model had 3Ks, and actually the accuracy level increased. And you go through each iteration of the model, And it seems like the highest accuracy level was achieved with a K of 9. So the ultimate K to increase the accuracy of this model is with a K of 9, and it will increase the accuracy to 0.34. Remember, the original accuracy of the model was 0.32, I believe. Let's see. Well, the previous, I'm trying to find, here it is. The previous accuracy of the model was 0.32, but and that was with a K of 4, remember? Because we initialized it with a K of 4. Here's the K of 4. Okay? But now we found out that the ultimate K is 9. When the K is 9, the accuracy goes to from 0.32 to goes to 0.34. And we did that by actually creating 10 different models with 10 different Ks and using the for loop, okay? Using the range. And that's the end of this video lesson. We created the model, the KNN model. Uh, we actually make some predictions. And if you guys like this video, please do me a favor. Subscribe to this channel, click like, and I want you to make comments in the comment section below. And again, please do not watch this video just for the sake of watching it. I want you to watch the video so that you can learn. You can apply this knowledge to your job. I want you to get a pay raise. I want you to get a promotion. I want you to become a machine learning engineer. So this is the second video on a series on machine learning algorithm. By the end of this video series, you should be a machine learning engineer. I promise you that. I wish you all well. Take care.